somehow. Okay, there we go. Um, and for the most part, everybody did a pretty good job. We're going to practice a little bit more today on the cylinders, and then we're going to move on to compound shapes, which are kind of a combination of the various shapes, cylinder, rectilinear forms, and even spherical, which is the last of the three fundamental shapes, although we're going to have a separate unit on spheres coming up soon. Suffice it to say, the compound shape is when we start putting together the shapes that we've learned thus far, applying the same ideas of constructive line drawing, diagramming, triangulation, angle finding, constellation when we're working on multiple shape, proportional relationships, etc. And that will kind of be, used or useful for every project that we do from now until the end of the semester. Bless you. That was a sneeze? Wow. But suffice it to say, what we're learning right now with cylinders and curvilinear forms that we'll get to as the class progresses today and into next week is vital when it comes to drawing organic shapes, especially, and human form in particular. So if you have any interests or aspirations in any way to represent the human figure, be it in a representationally realistic way or in a representationally abstract way, like anime or cartoons or video games, et cetera, et cetera, et cetera. Understanding constructive line drawing, number one, and curvilinear forms and how to measure those proportions is so important. I went ahead and I sent everybody in their email another set of reference images for compound shapes. So you have a bunch of different reference photos for cylinders that I sent you, right? And then this morning I sent a bunch of different shapes through your email that were compound shapes. Kaylee, did you get those?
Yeah, I got them.
Okay, good. So, have those ready. Obviously, we're going to be drawing from the class. But I want to talk a little bit more about cylinders and ellipses in particular. One thing that I noticed repeatedly in a lot of you guys is, that's very proper English, you guys is self-analysis, your self-critiques, was that you said that you were having trouble getting the ellipses to look symmetrical. So maybe the top curve was one sort of arc and the bottom curve looked deeper or shallower than the top curve. Is that the case? Did anybody have that experience in here? Bing did, Sandra did, okay. Everybody had that experience. How about out there in La La Land? Jonathan, did you have that experience?
Yes, definitely.
Okay. Ryan?
Yes, I did as well.
Okay, so everybody had problems with it. Oh no. Oh, I knew I had this pencil. This thing, the Apple pencil, I just lose it all the time. Or misplace it, I should say, not lose it. All right, so I'm going to share my iPad screen with you guys real quick. Hopefully. Teams. Joining. Okay. And I'm sharing. Okay, you guys should be seeing my screen now. And I'm going to open up Procreate. Okay, so the first thing, obviously, I want to stress this point very clearly. When it comes to drawing, process-wise, you always start light, guesswork, loose, arm-based, and you move to darker, forearm, wrist, finger-based, tight. Okay? You can see how those two things are polar opposites of one another. So one is very loose, and only the people in the classroom can see me acting crazy, and then one is very tight. Okay? The other thing, and again, we're talking about process, okay, is we work from general or simple to specific and complex. Mostly, sometimes. Sometimes it's not so complex, but it's more complex always than the more general aspects of the shape. So for instance, if we're looking at this object that I've got at the bottom left of my screen, this picture here, the most general thing about it is the height and the width, the rectangularity of it, the verticality of it. That's the most general thing, okay? And then as we move forward, we get into more specifics, like the ellipse, which is a little bit more difficult, a little bit more complex as far as being able to represent it and to measure it even is more difficult because it's such a small detail. It's one thing to measure, height and width using your pencil or your fingers to measure height and width. It's another thing to measure that ellipse. So we're going to start easing into something that is somewhat different in nature than the diagrammatic process. So let me erase this real quick. It's probably easier to do it a different way. Just imagine I'm standing up at the whiteboard, erasing the dry erase marker. All right, so far, we've been doing diagrammatic drawing or constructive line. I use those terms as if they're the same, and they are, basically. Constructive line is about constructing a shape using diagramming methods like triangulation, center line, finding height and width, finding vertical relationships, horizontal relationships, diagonal relationships, etc. And we talked about how in diagramming, it's really focused, it's very left brain, so mathematical, it's very objective, it's very controlled, and this is in opposition to the other type of drawing that we're going to start doing, which is called gesture drawing, which is more about not tightness, but fluidity. It's looser, whereas diagrammatic drawing as a whole is tighter. It's more improv or improvisational, whereas diagrammatic is very deliberate and careful. What's another way to express it. It's more about essential, whereas diagrammatic becomes very specific. So now we're not talking about process, we're talking about technique. Okay, so the constructive line technique, the gesture technique. Okay, the process is kind of the same for both. General to specific, looser to tighter, bigger to smaller, arm-based to finger-based, but one is much more slow and methodical, where the other one is more fast and kind of gut-based, okay? So we're gonna kind of start easing into that, which beautifully will make your drawings go quicker. You know, this constructive line technique is very slow. Now, just because we use this improvisational, fluid, loose, fast process of gesturing does not mean that we don't still look for the same things that we're looking at when we're doing constructive line drawing. We're just doing it more here than we are, and when I say here, people out in Teams land, I mean in our heads, than we are using our techniques of the pencil to find angles or height and width and things like that. So at this point, you're kind of starting to absorb what it is you're looking for when you're trying to represent something. Oh, I'm looking for height and width. Oh, I'm looking for angle. Oh, I'm looking for thickness. I'm looking for thinness. You follow what I mean? You're kind of already absorbing those things. I'm looking for the relationship of one object to another. I'm triangulating. But as you become more fluent with that, it kind of becomes ingrained in you, and you only need to use those constructive line techniques when you run into problems, when you're like, something's wrong and I can't figure it out. Okay, let me measure the height and the width. You follow what I mean? So we're going to kind of ease into gesture, but just recognize that you're still looking for the same thing. All right, and that brings me back to constructive line and the ellipse, which is what a lot of people were having trouble with. So let's talk about that real quick. Maybe it's faster to just do it this way. Maybe not. All right, so if you look at the picture on the left, you'll notice that I'm doing this oatmeal container that's on the table here in the classroom and in the photograph for you people out in Teams. You'll notice that in the top photo, I've got the top of the pencil on the top of the oatmeal container. The top is not the front edge, it's the back edge. We know that that ellipse is flat in space, and that if we were to measure from the bottom to the top in the front and the bottom to the top in the back, it would be exactly the same height. But because of our perceptual point of view, we can see inside that opening, and the back appears to be higher in space than the front. Does that make sense? It's magic. Woo! It appears to be higher, but it's not really. It's just like that table. The front edge of the table that you're looking at looks lower than the back edge of the table that you're looking at. Even though it's, get out your tape measure, it'd be exactly the same. You follow what I mean? So it's an optical thing that we're seeing here. So height times width, or height relative to width, I should say. So you can see me capturing the height, top of pencil, back of the ellipse, bottom, where your thumb is there, capturing the bottom apex of that lower curve, okay? Now, when you're doing this measuring, don't have your arm bent. Have your arm extended straight out, as locked as you possibly can have it. Why would I need to have my arm straight out, locked, as straight as I can possibly have it? Excuse me? Well, straight is one thing. Huh? It's easier to control in certain ways. Exactly. So Ming said you can go back to it, just like you can go back to your easel if you're relating to your easel one arm length away. So perceptually, it's more, what do you call it, secure, okay? If I do this, and then I come back here, I've changed the measurement. Like if I do this, and then I pull my hand back, it doesn't match up anymore. So like if I squeeze your head, and then I come back here, your head looks much smaller between those two fingers than if I've got my finger resting on the top of your head and on the chin. I'm crushing our head, right? Monty Python. So you've got to have your arm locked when you're doing that measurement. Now you see in the middle photograph that I've pulled away. So what I've done is I've just gone to the side so I can say, there's that measurement. It's kind of like when I do an angle and I pull it away and I look at it so that I'm seeing it abstractly, not relating to the table. Because that's two-dimensional. The table is three-dimensional. We're trying to make a three-dimensional thing on a two-dimensional page. You following me? So I measure that height, then I pull my pencil to the side, then I put my pencil horizontal to measure the width. And you can see there in that photograph that if this is the height of that oatmeal can, and I turn my pencil on its side so that the top is here and the thumb is in exactly the same place, what do you notice about the height to width dimension? It's half. All right, so if I'm drawing, and I say, I want to make my object this big. Is that as big as I can make it without going off the page? No, but I'm going to be dumb and not follow directions. So that means how thick is it going to be? It's going to be half of that height, right? Okay, so the next question is, well, how do I figure out how to get that on either side so that it's the correct measurement? Well, one thing you could do is go about a quarter, right? Make that distance here and make that distance here, or just do it here and then make sure that you're symmetrically placed on the other side. You follow what I mean? You have a wrinkly face, confused look. Do you get it? Oh, okay. So now I know that that is the size, width-wise, relative to the height that I've determined. Okay? But wait, Professor Wilson, you're drawing it too small. Okay. Is that better? Size-wise? Would it be better if I made it that big? Yes, it would be better if I made it that big. Where's the halfway point? Same place, right? But now the quarter's here. So I've got to get that distance away, and I'm going to use a different color. There's the quarter there, that distance away, and then jump over and get that same distance away on the other side. You see what I mean? And then I could take my pencil on my paper and measure that distance and compare it to the half distance and say, oh, it needs to be a little bit bigger. Okay? So I'm making changes. So now I can drop down my lines, which are vertical, right? And I know that this has got to be the bottom and this has got to be the top because that's what I decided. Does that make sense to everybody? All right, now, looking at that ellipse, it's really hard to determine from far away what the relationship of height and width is there, isn't it? Okay, well, right now on our page, we know the height and the width of our shape, okay? We know that this is the back edge of the ellipse, right? So what we're trying to do is it here? Is it here? Is it here? Is it here? We don't know, right? All right. So I'm going to, and here's where you guys, what I did not see in your drawings. I did not see that. And that's why you were having so much trouble getting symmetrical ellipses, because you didn't have the cross logic clear enough in your drawn, so that you could tell whether it was symmetrical or not. Does that make sense? So, Ming, what would your guess be as far as this height relative to this width? How big is this height if we were to compare it to that width? Is it a third of the width? Is it a half of the width? Half-ish? Would you say that's about the size of it? Yeah. What is that? Is that half? It's a quarter, right? That's about a quarter, right? So if we come back over to our drawing, where's a quarter? Here's our width. Is this a quarter? No. Is this a quarter? No. Is this a quarter? Yes? If this is the halfway point, is this the quarter point? 1, 2, 3, 4. It's not making marks? Oh, you may not be able to see them. Can you guys see the marks I'm making out there in Teams land?
Yes.
Okay. Does that make sense? Is that a quarter? Okay. All right. So if that's a quarter, then is this about 1/4 of the width? Yeah. So this distance is equal to this distance. You follow what I mean? Does that make sense? All right. So I'm going to go to my black tool. I'm going to lighten it a little bit. So the most important thing is that you have a center line here, that you find the center of that, okay? You still with me? And that you draw a line across that shape that's horizontal. Are you following me? Okay. So that cross logic that determines the height versus the width is determining this is the vertical line of symmetry, or the center line. And this is the horizontal line of symmetry, or center line. Does that make sense? All right, so as I'm drawing, what I'm determining to do is fit my ellipse within the boundaries of the side here and the boundaries of the height that I've determined with that vertical center line. You see what I mean? And what I'm looking at is I'm looking to see that this shape is a reflection, a mirror reflection of this shape. Do you see that? And this shape is meant to be a reflection of this shape. Do you see what I mean? So what I was seeing in a lot of your drawings was you were just doing this. Does that look right? No, if we put a center line, what do you notice about this quadrant or two quadrants versus the bottom two quadrants? The lines at the bottom are much wider, taller than the lines at the top. You follow what I mean? Like when you have that cross, it becomes so obvious. If you don't have that cross, this is why constructive line is so important. It's not as obvious. Now, could I correct it? Yes, because I'm awesome. And you're not. Wait, is that being recorded? Oh, no. But I could make a guess, right? And that looks at least better, right? You follow what I mean? So change it. If it's wrong, change it. If it looks wrong, change it. It was so funny because I was reading through your self-critiques and it's like, I think I did really good on the height and width, but with the ellipse, I feel like the back edge is shallower than the front edge. It wasn't just you, Lauren. It was Ryan. It was, I mean, it was everybody. And it's like, if it's not right, what are you doing? Change it. Now, what's the question? The question is my back edge wrong or is my front edge wrong? That's the question that you have, right? It's not obvious, but that's where you go back into the diagrammatic mode, the constructive line mode, and you try to guess or estimate the height and the width, right? And you just look and you say, it looks wrong. Something looks wrong. Take ownership. Now, as we come down here to the bottom, you're like, well, where does, we know that this is the bottom that we've determined. We could, let's make a guess. Does that look right? Oh, you can't see it. How do I get rid of that thing? Oh, there we go. Does that look right? No, that doesn't look right. What does it look like? It's too what? It's too deep. So if we were to draw a line up here versus our cross that we have here, it becomes very obvious what's wrong with it, right? Now, why am I drawing a line? Why am I drawing the line there and there? You need to know why you're drawing the line there and there. Yeah, that's the bottom corner of that vertical line, right? Just like this and this is the top corner of the ellipse. And I say corner loosely because it's not really a corner. You know what I mean? It is on the bottom, but it's not on the top. So if I was to do something like this, and just make a guess, does that look better? Yeah, because it matches that angle, right? Now, the other way to do it is to take this dimension and find that dimension, take this dimension and put that same dimension from the bottom. You follow what I mean? And then draw a straight line. And then we've got a similar shape to what we have here. Does that make sense to everybody? Okay. I know it seems complicated, but it's not really complicated. Okay. So I'm going to try one more thing, and then we'll do some drawings. Um, let's do the tuna can. Okay, so there's Charlie Tuna, right? Oops. Okay. So the first thing that I need to do is determine what kind of height I want to make him, right? That's our first decision. So I'm going to make him this big. Okay? That's how big I want to make the tuna can. Okay? Actually, you can't see anymore. I know. I'm going to make him even bigger. Okay? So I'm making him bigger. Right? So what, pray tell, is the height versus the width? Well, if I draw my center line, which is this, right? What would you estimate that height is relative to the width? Two-thirds. So if I take that and I measure it, huh? Let's see here. How can I do this? So there's our height, right? Sorry. I wonder if there's a way. Yes. What do you notice? It's about half. Okay? So that means I got to take this and I've got to have at least that height here, right? And then I got to do the same thing on the other side. You see what I mean? You understand, yes? Okay. And then, so we what did we do? We overestimated and underestimated. That's why measuring is so important with your pencil or with your fingers, okay? So now we know the width. Now, I'm going to just be crazy. Where's the back of the ellipse? The back of the ellipse is here, right? Because that's the height that we determined, okay? So my next question is, how big is that compared to our overall height? About 1/3, right? Good job, good estimation. So that would be about right here. Would that be about 1/3? Yeah. So now what do? We find the middle, because we want to know where the corners of the ellipse are. We draw a straight line. And then we try to match these quadrants. Does that look like a pretty good match? Then we take this dimension, we put it down here, we draw a line straight across, right? Because that's going to find the bottom corners of our ellipse. Does that look like the same proportions? that make sense? And then we can come in, and I'm going to just do something really quick. Let's see. No. No. I'm just going to kind of lightly erase over it so that all I can see, because I would have drawn this much lighter had I been drawing with a pencil, right? Does that make sense? So now I can start looking at little details. Like I noticed that there's a little bit of a rim to that thing, right? Does that make sense? You see the little rim there? So I can do this. See what I'm doing there? I'm kind of creating dots that are equidistant from the bottom of that ellipse, right? Just little lines of direction. That way, when I want to connect them, I can have a consistent thickness. So now I'm getting into details, right? The specific details. And then this is going to be here. And that's going to be there, like that. Does that make sense? Now, we see it on the inside, too. So I'll make a little mark, a little mark, a little mark, a little mark, a little Matthew, a little John, a little Luke. Now I have the inside rim. You see what I'm doing there? You smelling what I'm stepping in? Yes? Okay. So let's do a couple more cylinders, maybe 2 or 3, and then we'll reconvene in about 20 minutes after we've done 2 or 3 of them, okay? Is everybody out there good? Hanging with me? Ryan?
Yep.